NASA releasing a full batch of images and data from the massive James Webb Space Telescope.
Will the era of astronomy be divided into a time before and a time after the James Webb Telescope? Well, the answer is obvious. After all, Webb is constantly tracking down mysterious structures in the depths of space that, according to our current understanding, are simply impossible. This refers in particular to those galaxies that formed immediately after the so-called Dark Age and which appear to be much too large and massive for their point of origin so shortly after the Big Bang. In fact, our standard model of cosmology cannot explain the existence of such early galactic heavyweights. But now, the astronomical tide has turned, and a team of experts is sure they have finally cracked the mystery of the so-called universe breakers. The view of the starry night sky is simply overwhelming. Under favorable conditions, it's actually possible to see up to 6,000 of these twinkling objects with a naked eye from Earth. And since the universe is truly not stingy with its luminous attractions these days, the following is all the more surprising. In truth, the universe was once a place of absolute darkness. If we turn back the wheel of time to 380,000 years after the Big Bang, we find ourselves in a cosmos that was nothing more than a hot and dense ionized plasma. However, the universe then cooled down enough for the protons and electrons to combine to form neutral hydrogen atoms. The crucial thing, however, is that during this so-called Dark Age, there were no light sources, stars, or galaxies, just a transparent neutral space filled with a dense fog of hydrogen gas. That the universe's light was switched on again in the period that followed is thanks to the first stars and galaxies, which were born around 100 million years later and gradually reionized the gas through their ultraviolet radiation. In other words, the electrons were separated from the protons, leaving them as free particles. And although the cosmic twilight era still raises many questions today, the James Webb Telescope has already shown us that it sometimes took a very different course than previously thought. Specifically designed for infrared astronomy and 100 times more powerful than its scientific predecessor Hubble, one of Webb's main tasks is to detect the first luminous objects and galaxies to have emerged from the Dark Age and to understand why the discoveries made by the $10 billion device so far seem so surprising, not to mention impossible. We should briefly recall what kinds of structures the experts had expected to see during this phase of the cosmos. In fact, astronomers had expected to see only tiny baby galaxies for this early chapter of the universe, and for a very simple reason. According to our standard model of cosmology, there was simply not enough normal matter at that time to pave the way for full-fledged galaxies the size of our Milky Way. But against all expectations, Webb ultimately uncovered exactly that. 6 galactic primitive babies that already existed 500 to 700 million years after the Big Bang and, despite all that, were already as developed as the Milky Way is today. Specifically, this means that all the discovered objects already contain more than 10, and in one case even more than 100 billion solar masses of stars. But how is that even possible? Well, the first answer that crossed Joel Lehar's mind was not at all, which is why the co-author of the study from Pennsylvania State University initially assumed that he and his colleagues must have made a serious mistake. However, subsequent review showed that this was simply not the case, so that since then experts have been confronted with some rather confusing excesses of the cosmos which stand in stark contradiction to our established assumptions. Has the standard model of cosmology become obsolete? In this context, Lehar finally said that this discovery came as such a surprise that it presents a real problem for science. In line with this, co-author Erica Nelson from the University of Colorado at Boulder added that our understanding of cosmology is reaching its limits if even one of the found galaxies turns out to be real. But why is that so? Why do 6 unexpectedly massive galaxies, which appear as mere red dots in the sky, have the devastating potential to suddenly overturn everything we thought we knew about early cosmic evolution? Well, it's quite simple to explain. For the existence of such massive galaxies at such an early point in time, the density of matter in the young universe would either have to have been 2 to 5 times greater than our models suggest, or the galactic heavyweights would have had to have formed in a way that is still completely unknown to us. But that's not all. True to the motto, one astronomical impossibility rarely comes alone. Webb was to add a few more objects to the star charts in the period that should not actually exist according to our understanding. For example, there is the galaxy with a scientific designation JWST 14-0, which existed as early as 290 million years after the Big Bang, and which also appears to be much too large and starry for that. The same applies to the so-called red monsters, which were revealed by Webb's NICAM near-infrared spectrometer and immediately caught the attention of Mangwan Shiro from the University of Geneva. To be more precise, we are dealing here with 3 galaxies from a time around 1 billion years after the birth of the cosmos, which were almost as massive as the Milky Way is today. In addition, the red monsters also appear to be extremely efficient star formers. While only a few new stars are formed per year in our home galaxy, the respective star formation rates in their monstrous counterparts amount to 795 to 1,030 solar masses per year. Surprisingly, however, the red monsters do not seem to contradict our standard model. Shiro states that ultimately no impossibly high density of matter is needed in the young universe to explain the existence of the structures. Instead, the key to galaxy growth in this case lies in the extraordinary conversion rate. While young galaxies can usually only use about 20% of the available gas for star formation, the red monsters have somehow managed to bypass the numerous factors that usually limit star production and achieve a conversion rate that is 2 to 3 times higher. But how do they manage it in the first place? Well, that's a question that is yet to be answered conclusively. All we know for sure is that everything indicates that the universe in its early days was 2 to 3 times more efficient at growing galaxies, but what enabled it to do so is still an unsolved mystery. But what may no longer be an unsolved mystery are the true origins of the supposed universe breakers. A team of experts has finally provided an explanation for the impossible early galaxies and shown that they could in fact represent something quite different. What are the mysterious red dots really? If you didn't make it to the 245th meeting of the American Astronomical Society in person this year, we'll be happy to give you a brief update. Before the gathering of the astronomical creme de la creme, a team led by Dale Kochevsky from Colby College in Waterville, Maine had devoted itself to the task of evaluating the largest data set to date on these little red dots, LRDs for short, and made an astonishing discovery. It now seems likely that the light emitted by these objects, which has caused so much concern among experts in recent months, is not actually of stellar origin. After Kochevsky and his colleagues had re-examined the spectra of the LRDs, they realized that a large proportion of them showed evidence of very rapid motions of up to 1,000 kilometers per second, and a pattern like that does not point to very early massive star clusters, but rather to the typical accretion disks of black holes. In detail, this refers to the disks of gas and dust that surround the gravitational monster at its center, constantly feeding it new matter. When applied to the supposedly impossible red dots of light, this means nothing more than that about 70% of the LRDs found are not inexplicable galaxies but growing black holes, also known as active galactic nuclei. And where the majority of the light does not come from stars but from accreting black holes, it follows that an impossibly high density of matter is not needed to explain their existence. But what does this mean for the big picture? Does this mean that the greatest astronomical crisis of our time is now finally a thing of the past? Well, we shouldn't be quite so hasty yet. After all, this new solution hypothesis also faces some problems. For example, there's the fact that the corresponding black holes appeared in large numbers about 600 million years after the Big Bang and abruptly decreased again about 900 million years later. What this development is all about has yet to be discovered. However, one possible explanation is based on the approach that with the spread of star formation, the amount of dust and gas in which these LRDs were previously immersed also decreased, so that the emitted light gradually shifted from red to blue. As a result, the little red dots would not have simply disappeared from the cosmic scene, but would have merely taken on a color that cannot be detected by Webb. But that's just a theory, and so far the case of the little red dots has not been definitively cracked. Despite all this, however, the experts emphasize that we are on the right track and that it is now all the more important to compare our existing models with real observations in order to find a balance between what agrees well with both. And we think that your click perfectly matches the balance between the thumbs up and the subscribe button. Become a part of our community now to never miss a new video from us again. We'll see you soon.